I've had to diagnose vacuum and evap leaks on my vehicles multiple times, so I decided it was time to own my own smoke machine. Professional grade units will run about $800 on the cheap end for like an OTC leak tamer or the smaller redline units. And I made one that, although uglier, will work every bit as well for about $50. The only thing this will not do is the leak volume testing, but there's modifications on the internet where you can add a water column loop that will do leak testing for you. If you need to identify the size of the leak, this is just a simple smoke machine that you inject in a vacuum or an evap system, and it will show you where the leaks are. Mine I made out of a 1-gallon steel paint can, new from a hardware store, for $5. We'll start with the electrical side and move to the pneumatic side. So I've got probably the better wire clips that I could find locally. Pretty much everything you buy from AutoZone or Walmart is copper-coated steel. Harbor Freight just had really crappy steel-stamped alligator clips. These are still copper-coated steel, but they at least have some teeth on the inside of the clamp and on the sides that will make a little bit better connection, and the spring is stiffer. So these are actually some battery tender clamps that were $5 from Northern Tool. I soldered on a inline fuse. If you decide to make this, you can use whichever size fuse holder you want. This is the micro size. I have a 10 amp fuse. I found that this unit will draw close to 8 amps at full load, so a 7.5 amp fuse would have blown too easily. There was no way to crimp a ring terminal onto these, and try to get this off. There's no way to crimp a ring terminal on, so I had to solder. The clamps on the ends were not enough to crimp the wire on, so I just loaded it up with solder and heated it for a really long time, and it's perfectly secure. The other connection is a adhesive lined heat shrink butt connector, so this is completely moisture proof. The wire is tinned copper, so it's marine grade, and then I've got heat shrink on the ends just to make it look nice. I've got a 10-foot loop of cable. This is 12 gauge wire, so it's bulky. If you were going to make this at home, you could do 14 or even 16 gauge wire. I found that running this about half power is sufficient, so 4 amps on 16 gauge wire is perfectly acceptable. The wire goes straight to the end terminals of this dimmer that I got off eBay. It's designed for 12 volts. I think this is for LED lighting. It was $4 shipped, and all the way to the left is off, and it's just a single knob for on-off, and you can vary the power that you want to supply. The output side, I've got 14 gauge wire that's running through. This is a section of just a small hose that I slipped over the wire to neaten it up and protect the wire. So here at the bottom, the wire goes out. I crimped ring terminals on the end, and I've drilled 2 holes and made binding posts to take the electrical connection inside the can. I ended up using 6 nuts per binding post, 3 on the inside, 3 on the outside. 2 of them secure the post to the can. And this is a rubber washer with some RTV behind it to make a pressure seal. And then there's some various washers and lock washers to make all that work. But you want the electrical connections insulated from the can. You don't want any continuity, or you're going to blow your fuse real quick. That's pretty much it for the electrical side. except for the heating element itself, which I'll show you when I open the can. On the pneumatic side, you use regular shop air, and you plug it in to this is a female 1/4 inch air hose fitting, and I had a 2-inch 1/4 inch nipple that I screwed into a galvanized 1/4 inch T-fitting. You could use brass for this, but brass fittings are ridiculously expensive. Like this fitting in a brass is $10. This is $2.50. A 2-inch nipple like this in brass was $5 or $6. This was like $1 or $2. I did have this brass fitting in the shop, so I just used it instead of buying it. This is a 1/4 inch to 1/4 inch hose barb fitting, and all this hose is 1/4 inch inner diameter vinyl hose. Rubber hose would have been better and more flexible, but it was a lot more expensive. And I kind of like having the clear vinyl hose so you can see the smoke in the tube. The end cap is a cap from an RTV tube that just happens to fit over the end of the hose. And this one is graduated for different sizes of hoses. I would prefer one that's just a cone shaped. Maybe different RTV tube will come with something different, and I'll replace this eventually. But so after the shop air comes into the T, I have a low pressure gauge. This is 0 to 15 psi in 1/4 psi increments. It's really important that you don't put more than half a psi into an evap system. There's a pressure transducer in the fuel system that reads low pressure, and so you don't want to feed shop air into an evap system, or you risk blowing out seals on connectors. You risk blowing up that pressure transducer. So it's critically important that you don't put more than half a psi in there. Some people will use a propane regulator, which is will do 11 inches of water column, and the math works out to about 0.3 psi, and you're allowed up to 0.5, so 0.3 is a little more than half of the allowable amount. So I wanted to do the full half psi, and I wanted to have some verification that that's what I was doing. So that's why the low pressure gauge is there. I have this hose that I have that's just a male air hose inlet with a inline pressure regulator and a 1/4 inch female quick connect on the other side. So this is what I plug in to my setup, and to get the variability that I want out of this regulator, I'll actually take my shop air compressor and regulate it down to 10 or 20 psi, depending on if I'm doing evap or vacuum testing, because vacuum testing you can put a little bit more than half a psi in, which will help finding leaks in a vacuum system. So that tube, my outlet tube, just goes to the top of the paint can. I had another similar fitting to this. It's a 1/4 inch male pipe thread to 1/4 inch barb. This one's just plastic. Mainly if I ever have to cut this hose off, these are cheap and easily replaceable. Then I have a fender washer and a metal rubber washer between that with some RTV on it to seal it. And then on the inside of that, I have another washer and a rubber gasket. And pipe thread nuts are almost impossible to find, but if you get a female air hose fitting and you cut off the air hose fitting part of it, you end up with a pipe thread nut. So these the steel threads are real cheap. They're 99 cents. whereas the brass threaded quick connects are more like $2 or $3. So I just got a 99-cent steel one, cut the air hose fitting part of it off, and I'm just using this as a nut. So inside the can is the meat and potatoes of this whole system. All in the world these smoke machines are is some mineral oil. Some of the OEM fluids have dyes in it as well. And I have 2 tiki torch wicks that extend down into the mineral oil, and then wrapped around the mid portion of the tiki torch wicks is a special resistance wire. This is a 20 gauge nichrome wire that I bought off eBay, about 25 feet for like $4 or $5 shipped. So all these components are super cheap. And that wrapped around the tiki torch wick, when you pass 12 volt current through it, will vaporize the mineral oil, and that's what produces the smoke. And when you put air pressure into the can, it forces the smoke out the top and out through your hose. And that's how this really works. So as you can see, the guts of this are really simple. The mid portion here is just another galvanized nipple. This one's 4 inches long that I drilled some holes in to direct the airflow. It's kind of pointed right above the wick there, so it's not blowing directly on it, but it's slightly above it to kind of force air up. But I didn't want the holes straight up, or I would have been blowing regular shop air up through the top of that. So I wanted to encourage the smoky air to go to the top of the can, and the other air to kind of circle and make a vortex around it. You don't have to do this. This is just an adaptation I saw on the internet that I thought I'd try. If you do that, you're going to need a cap on the end of the pipe there to seal it off. And then I just drilled 1/8 inch holes. And there's no rhyme or reason to the number or the spacing. I just wanted it to come out of the particular side of that nipple. And then I used a female-to-female union coupler to go on the other end of this hose barb here. So I've got a hose barb. It's a right angle connection. This is one I had. It was a 1/8 inch pipe thread. So this union is 1/8 of an inch pipe thread to 1/4 inch pipe thread female coupler. And all that is kind of unnecessary. Really, you just need something sealed on the inside of the can there to put air pressure in the can. But the guy on the internet that I was reading, his experience was that this made a positive difference. So it's something that if you're on a really strict budget, you don't have to do. If you got a few extra bucks, you can put that in there and maybe it'll perform a little bit better. On the inside, you can see the binding posts for my electrical connections. They're pretty much the same as what I did on the outside. I ended up crimping a ring terminal on the end of the nichrome wire because I've got the crimp tools to do it. Some people will just put a little loop in it and wrap it around a binding post and secure it with a couple nuts. Soldering will not work because this wire will get hot enough to melt solder. Using 20 gauge, this probably won't get red hot. If you use like a 24 gauge nichrome wire, it might. So the big draw to this system is it's not going to get hot enough to reach the flash point of gasoline, and this whole thing is sealed. So I think this is a safe way to do it. A lot of the old smoke machines use a diesel glow plug instead of the nichrome wire, and the tip of the glow plug does get hot enough for the flash point of gasoline. And so for some reason gas vapors got into this. This one won't explode, whereas an older one that has a diesel glow plug would. One thing I'll note is that I don't see a lot of people using an inert gas to do evap testing. I just use shop air that is not recommended by the OEMs. They say that inside a gas tank is too rich to spark a fire, and by pumping shop air in, you're putting oxygen-rich air in and forcing out that extra rich gas vapor out of wherever your leak is, and so there's the potential for explosion there. So I'd say use this at your own risk. Plenty of the mechanics that I've talked to say they don't bother with an inert gas like an argon or nitrogen. They just use shop air. Just be smart with it. My fuel tank is over 75% full, so the fuel tank is deep enough to cover the top of the fuel pump and all of the electrical connections down there. So if there was something damaged inside, it should be covered in gasoline and not able to spark. The only other thing that I'll note here is this lead battery clamp is clamped onto this nipple. I had to wrap a couple wraps of foil tape around it to bring the nipple up to a diameter that this clamp would grab onto. That's the only reason for that nipple, is to give the clamp something to bite onto, because there's not enough of the T there for it to grab, and there's not enough of that female fitting for it to grab. This is just an aluminum plate that I have secured my dimmer and my pneumatic couplings to. You can use whatever you have lying around, a little steel plate or something with some holes drilled in it. That's pretty much it. As you can see, this thing is super simple. There's absolutely no reason to pay $800 for a professional grade unit when all that's inside of them is essentially this. Nichrome wire wrapped around a wick that is dipped in some mineral oil. A lot of the OEMs will say that their fluid is not just mineral oil, but in their frequently asked questions they'll say, well, yeah, the base is mineral oil, it's just really, really pure. So this mineral oil is food grade. It's you can do mineral oil USP or food grade, or some purified version of mineral oil you can get at Walgreens for like $2. I just dumped the whole bottle in there. It's below the level of all of my penetrations. So even though they should be fluid tight, you wouldn't want to store this on its side. Keep it right side up, and you should be okay. I imagine that this mineral oil was probably going to last for years and years. A lot of the professional units only put 2 ounces in for them to be full, but their cans are smaller. So this is a large can, so in order to get the mineral oil up a couple inches into the wick, I just use the whole 16-ounce bottle. Adds a little bit of weight to this unit, but I'm planning on putting it on the ground. A lot of the OEM units you can hang from a hood support, which I'm probably going to rig up a way to do on this one. I've got a hole here that was in the plate. I could put a hook here and hang it on the hood latch, and this be okay. I was hoping to bend my aluminum rod. This was actually a little bit longer when I built this, and I started trying to bend it, and the threaded rod was, I guess, so brittle that it just snapped off. So I was going to make an integrated hook, but that didn't work out. So I'm glad it failed during the build process in the shop rather than hanging from a vehicle. So this didn't just bare threads. I took some of the same little tubing that I passed my electrical connections through and put a little cap on it with some heat shrink, and it slides over the top there. And then I just have a reusable plastic tie for my air and electrical lines. That's it. Wanted to show something that it didn't show the build process because there was a lot of experimentation and fitting to make sure it was like I wanted it, but as you can see, there's nothing here that really is complicated. All this is pretty self-explanatory. The bottom of this threaded rod, this is the only thing I haven't shown, is just a piece of sheet metal that has a right angle bent in some little tabs to hold the paint can in place, and then there's a right angle here, and I supplemented with a right angle bracket, and that's what's holding my threaded rod. You can see the nut for the threaded rod. It goes up to there's a nut here, and I just bent a little piece of metal to make a clamp between these two nuts, and it holds it onto this bracket. And the threaded rod is actually going through a hole in the sheet metal bottom that's bent, so you can pick this thing up from the threaded rod and it's secure. Because there's nuts on the bottom, I did have to use some like rubber feet to make it level. As you can see, I've got those right angle tabs, on four places on here to retain the paint can. That's it. Thanks for watching.